So now let's look at a very special circle, which is called a unit circle. So the unit circle means a circle centered which is x squared plus y squared equals 1. So this tells you that the center is what? Is the origin is 0, 0, and the radius is 1. So this is called a unit circle. So here is this point is 1, 0, and this point is negative 1, 0, and this point is 1, 0, 0, 1, and this point is 0, negative 1. So this is called the unit circle. So now let's look at the trigonometry function on the unit circle. Okay, so if we have a unit circle, right, and this is a ray, so here intersect the unit circle at this point. If this is theta, so the unit circle here, the radius is 1, right? So here this is 1, the length is 1, and this part, yeah, the length is 1, and this is theta. And if we have, if we denote the arc length s by s here, so for the unit circle, there's one thing is we know that s is equal to r, the radius, times the central angle, right? So now r equals 0 equals 1, so r equals 1, so we have s is equal to the central angle. So in other words, it tells you that in the unit circle, the arc length of the sector in unit circle, the arc length of a sector is equal to the measure of the central angle, which means the here the measure means the radian measure. Okay, so this is the one thing. And now let's look at the trig function values, right? For the unit circle, if this is theta, and the intersection point here is this is the xy. So the radius we know it's equal to 1, right? The radius is 1. So, so here is also equal to 1, right? So the distance from this point to the origin is also equal to 1. So we know that sine theta should be equal to what? Equal to y over r. So it's equal to y, right? Cosine theta is equal to x over r, which is x. And the tangent theta is equal to y over x. Here x cannot be 0. So in other words, if theta is 0 degree or 2 pi, then tangent theta is undefined, right? If theta is pi, then the tangent theta is also undefined. The tangent theta, if the theta is pi over 2, then in here, right? Theta is pi over 2, so the intersection xy point is here, so x equals 0, so the tangent theta is undefined. If the theta is 3 pi over 2 here, right? This is the tangent theta is also undefined. So this tells you one thing, that if you have unit circle here, right? And this is the point. If you have this theta, then this point is xy. We know x equals cosine, so the x coordinate is actually cosine theta, y coordinate is actually sine theta. Right. So now let's look at this example. If you have a unit circle, and our theta is this one, and this point is -3/5 and 4/5. So what we can get? We can get that theta, cosine theta is equal to what? -3/5 sine theta equals 4/5, right? The reason is this one. And then tangent theta equals sine theta over cosine theta, which is equal to -4/3, right? And we also can, now the next thing is we want to get the domain. So theta, the cosine and sine is a function of theta, right? So we also can get the domain and the range of sine function and cosine function. Okay, sine function and cosine function. So here we use the unit circle. You can see it very clearly. If you have a theta here, and this is the x and y, right? And we know that y is actually equal to what? Sine theta, right? We just calculate. So the theta is the angle, right? You can rotate this bar as many revolutions as you want, right? You can rotate counterclockwise, you can rotate clockwise, right? So you can get theta is anything, right? There is no restrictions on theta. So theta is from -infinity to infinity. You can have any angle you want, no matter how large it is, no matter how small it is, right? So it's a real number because we use the radian to measure this theta, this angle. And the range y values. Y, we know this is y is the y coordinate. So here is 1 and here is -1. This is y-axis, right? This is the x-axis. Here's 1, here's -1. So you can see that this y is actually what? Y is actually from -1 to 1. It will never be greater than 1 or never be less than -1, right? And we also have x equals cosine theta, right? Cosine theta in the unit circle. And again, this theta is from -infinity to infinity. And the values of cosine theta, which is x from here is from 1 to -1 also, right? So x is from 1 to -1 to 1. Right. So the sine function, cosine function domain is from -infinity to infinity. And the range for the sine function, cosine function is always from -1 to 1. And we also have another property for the trigonometry function, which is called the periodic function. Periodic function. So now let's look at the general case for the periodic function. We say this one, function f, t plus c is equal to f of t. So here, c is greater than 0, then we say this function is a periodic function. And then we give a name for the C. C is the smallest number C, positive number C, is called period of f. So if you add a C, then after C, then the function value will be repeated for every C, okay? So the sine function and the cosine function are actually periodic function. Actually, all the trig functions are periodic function. So here I would just talk about the sine and cosine, and we know that if you have this one, right? This is the x and the y, right? We know that the coterminal angles, right? So theta, if theta is here, right, then you have the sine value, which is y coordinate of this point, right? If we rotate one more revolution, get the coterminal angle, then the sine of this coterminal angle is also have the same value y, because they have the same terminal side, and this point is always the same, right? So this is the smallest number. We add a 1 revolution. This is the smallest number we can take, right? If we add a number which is less than 1 revolution, we may not get the same point. So the sine, same value, not the same point, same value. So the sine function plus a 2 pi is equal to sine theta. And this 2 pi is the period of the sine function. Similarly, you can have cosine theta plus 2 pi is also equal to cosine theta. Cosine value is the x coordinate, right? The same thing. You add 1 revolution, you will get the same value. And this 2 pi is also the period of cosine function. Okay? And we're more general. We can add 2 pi. We can also add another 2 pi, right? You will still recover cosine theta. So, in general, we have, right? Since every 2 pi, it will be repeated. So we add a 2 pi, we add a 2 pi, we add a 2 pi, it will not change anything, right? The value is always equal to sine theta or cosine theta here. So now let's take a look at a very general case that sine theta plus 2 pi times n, a multiple of revolutions, okay, which is equal to sine theta. The reason is quite easy, because theta plus 2 pi times n, which is the coterminal angles of theta. So the angles share the same terminal side, so the function value should be the same, right? Although they are two different angles, right? I didn't say these two angles are the same, but they share the same values for the sine function and cosine function. And the cosine theta plus 2 pi n, so this is a multiple of revolutions, right? A multiple of revolutions, so we know it's the coterminal angles. So the coterminal angles with the theta, so they have the same cosine value because they share the same terminal side, cosine theta. So here n could be 0, do nothing, plus or minus 1 revolution, clockwise or counterclockwise, plus or minus 2 revolutions, clockwise or counterclockwise, plus 3, and so on, all integers. So this is a very important formula, right? And for the functions, we also want to know what is the even function and odd function. Okay, even function and odd function. So now let's look at this one. This is theta, right? This is the x and y, if this point is xy. And this is, if we rotate clockwise, you get negative theta, right? The same size, but different rotation. So we notice that sine negative theta is equal to sine, what's this point? This point, this is the x, so here is also x, the same x, but negative y. So sine negative theta equals negative y, right? The y coordinate. And this is the reason. Okay, so here is the properties we have, right? On the unit circle, the y coordinate is always the sine theta, right? Sine of the central angle. And the x coordinate is always the cosine of the central angle. So now our central angle is negative theta, so sine of the central angle should be equal to the y coordinate of this point, so it's negative y. So we know that y is equal to sine theta, so it's negative sine theta. So you will get sine of negative theta is equal to sine theta. What does this mean? This means sine function is an odd function. Here is negative. It's an odd function, right? Sine is an odd function. Similarly, you have cosine of negative theta. Cosine of negative theta equals x, right? And x is also equal to cosine theta, so it's equal to cosine theta. So this means it's even function, right? So here, just a quick reminder, what is even means. Even means f of negative t equals f of t, and odd means f of negative t equals negative f of t, right? So sine of negative theta equals negative sine theta. Cosine of negative theta equals cosine theta. So similarly, we can get tangent, right? Tangent negative theta. Tangent negative theta equals what? Equals, we know it's equal to sine negative theta over cosine negative theta, right? Sine negative theta equals negative sine theta, and cosine negative theta equals cosine theta, right? So it's equal to negative tangent theta. So this tells you that tangent negative theta equals negative tangent theta, so this is the odd function. Tangent is odd. And the cotangent is just 1 over tangent, so it's still odd function. Right. Cosecant is 1 over sine, so it's odd function. And secant is 1 over cosine, so it's odd even function, sorry. Right. So now let's look at other examples. So we're going to calculate 13 pi over 6. Okay, so here is the one thing that we want to, this angle is too large, right? So we want to decrease the size of this angle, but do not change the sine values. And we notice that it's equal to the sine of 2 pi plus pi over 6. And we know that 2 pi is the period, so it's equal to sine of pi over 6. Sine pi over 6 we know, which is equal to 1/2. Right? Cosine negative 7 pi over 2. Right. So there are many ways to do that. Let's look at one way, which is cosine can be written as negative 4 pi, so negative 2 times 2 pi, so it's a multiple of 2 pi, right? Plus what? Plus pi over 2, right? So it's equal to, this is a period, right? This is a multiple period, so it will not change the cosine value, so it's cosine of pi over 2, and it's equal to 0. Or you can use another way, which is we don't like the negative, so we use the even and odd properties. So cosine is an even function, so it's equal to cosine 7 pi over 2. So 7 pi over 2 is actually equal to 2 pi plus what? Plus 3 pi over 2, right? So it's equal to cosine of 3 pi over 2. 3 pi over 2, which is 0. Cosine is 0. Right, 3 pi over 2 is on the negative y-axis, right, the terminal side. So cosine of this angle equals 0. So if we can change, at last we can change the angle between 0 and 2 pi, then we can get the answer easily. Right, you can use the even and odd properties to get rid of the negative sign, and you can use the period to shrink the size of this angle. Okay.